How does ESCOM generate electricity to households?
Electricity requires a fuel source. At this plant, the fuel source is coal, which arrives mainly by a barge but also by rail and truck. Each barge delivers 1,500 tons of coal, enough to keep the plant running for a couple of hours. The plant uses about 21,000 tons of coal each day, so over 1 million tons of coal is stockpiled next to the plant. A device called a stacker reclaimer scoops coal onto a quarter-mile long conveyor that can transport up to 900 tons of coal into the plant each hour. Once inside the plant, up to a 30-hour supply of coal can be stored in bunkers. Coal moves from the bunkers to feeders to be measured and moved to pulverizers. Each generating unit has 16 coal feeders that supply 8 pulverizers. Coal enters the pulverizer and spins in a large drum, where hundreds of steel balls grind it into a fine powder. Now a fine powder, the coal leaves the pulverizers and heads to the boiler. Large fans add warm air to the powdery coal and blow it into the boiler. The boiler has miles of tubes filled with high-quality water. Once inside the boiler, the coal ignites, releasing energy and generating intense heat that changes the water inside the tubes to hot, dry steam. The temperature of the steam is now about 1,000 degrees Fahrenheit. This process generates thermal energy, which is transformed to mechanical energy at the turbine. High-pressure steam, now 1,000 degrees Fahrenheit at 3,500 pounds per square inch, is piped from the boiler to the first in a series of turbines. Here it expands between layers of turbine blades mounted on the turbine shaft. The steam loops back to the furnace, then onto the second turbine. In this process, the steam turns the series of turbines 3,600 revolutions per minute, providing power to the generator, the last in the series of machines. The generator continuously creates an electrical charge of 34,481 amps at 18,000 volts of electricity. From here, the electricity leaves the plant and begins its journey to customers. Transformers located just outside the plant boost the power from 18,000 volts to 345,000 volts, so it can travel long distances over transmission lines to where it is needed. Substations located along the path reduce the voltage so it can be moved along distribution lines attached to the utility poles. As the electricity nears customer locations, transformers on poles step down the power for use in homes and businesses.